that we are back live, and I will go for the mixed view. So, any questions regarding kind of like the more theoretical aspects of requirements? I've only kind of like touched on a little bit of the important topics, specifically that there are different types of requirements. You can view requirements from functionality or non-functionality perspective, from product or project perspective. Think about especially the important qualities, the important non-functional requirements in the start of the project is a good thing because they have a tendency to affect many things to come. And also the ethical and legal requirements that you may and or may not have as in your projects. So, getting maybe a little bit more practical, the assignment. So, for the second assignment, you need to do some planning first. That is, you need to kind of like get an overview of what you are supposed to do. Divide this end goal into some chunks of some granularity and make an estimation of the chunks, and then track the time that you actually take to perform these tasks. Of course, you can use the assignment itself as at least the first level of granularity, but maybe you can divide it even further. For example, well, to know about use cases, I probably need to study the book or study some resource. I will allocate 2 hours for that. Then I need to write this use case. I think that will take at least 2 hours, and so on and so forth. The important thing is here is not to know exactly, to make good estimations to start with, because you have probably never done a use case before in your life. So it's really, really hard to know how long it will take. The idea is to practice estimation, follow that up with reality, learning along the way to become better at estimation as time goes on. So don't be afraid of doing estimations, and estimations are hard in general and even harder when you don't have the experience. So practice, practice, practice. Make estimations, track your time, think about why is it such a difference? Well, I should probably divide use cases up into these parts instead. I will try that next time. Oh, databases are really hard for me, so I probably need to allocate more time into that. Or PHP is really easy, so I did not need as much time as I thought for implementation. So that is the first thing you are supposed to do. The second task is about requirements, and basically you will write a requirement. You will get some requirements, get a first feel of the system that you are supposed to develop, and then you add details and possibly even more requirements depending on your level of ambition in the project. The third task is about modeling the behavior of the system, and the final task, or maybe the final task is doing some implementation, and then finally doing a model over the implementation that you have made. But we will talk more about actually doing the requirements for task number 2 during the remainder of this session. So you will be using use cases. Present. So, and use cases is one way to elicit, that is, capture, get the requirements from some source, and document the requirements and the goals of the users. They're not the only way, it's one way. It's not the best way in every situation, It's a good way in some situations. In a real project, you probably need a mix of different types of documentation strategies for your requirements. A simple way is to just put down the system shall do X, the system shall not do Y, the system shall do Z in long lists. That's one way of doing requirements. Can be really good and effective for some types of requirements. Some other types of requirements require a little bit more thought, maybe. And use cases is one way that we will use, because they are based on they are good for interactive systems where you have a user that wants to fulfill some goal by doing some steps using the system. So it's more tightly connected to the user goals in many ways. They are also kind of like a good starting point for modeling, which is the next step. So we will be using use cases. And they are scenario-based, so they are based around small stories, you can say. You write a little story about what the user does and what the system does, and what the user does and what the system does, and finally you have some end result from that interaction, from that sequence of input and output. And that's called a scenario. And basically use cases are text documents. So when you do almost anything with requirements and use cases in particular, you will write text. That's what you are doing. You also have use case modeling. And that's more about organizing the requirements at different levels to avoid text duplication. So if you spend your hours upon hours on doing kind of like diagrams or models like this, and very little time writing text, you are doing it wrong. You should be writing text. That's the main artifact. This kind of like diagram is just kind of like a byproduct or something to help you. Don't spend too much time on use case modeling. And the essence of use case modeling is simply that when you write code, for example, sometimes you use copy-paste, right? I probably think that all of you have copied some code. You have pasted it in maybe several locations in your program. Is that a good thing? Can be. It's an easy way to reuse, right? The bad thing is that, well, it's not that good to maintain that code because it's kind of like everywhere. So if it's a bug in that code, you suddenly have bugs everywhere, and you need to remember all these places that you need to fix this bug, and that's not a good thing. So what's the kind of like other approach to doing? Instead of doing copy-paste, you should... What do we do instead? Reuse. We reuse, yeah. Copy-pasting is a form of reuse, but there are other forms also. And what are you thinking about?
Maybe making a method.
Exactly, exactly. We should make a method. We should take the common functionality, put it in a function, a method, a class, or whatever, and use parameters to that if we need to. But kind of like this concept of not copy-pasting everything everywhere, but having a central point, and we can call that central point instead. It's the same thing actually with use cases. We may end up in a situation where we have the same text in several different use cases. That's not interesting from a maintenance perspective, for example. It's hard to maintain. It becomes long and tedious to read. So instead, we kind of like take the common parts and we can break that out into separate use cases, and we can call these separate use cases from the main use case instead of copy-pasting the text itself. So for example, you are writing kind of like the order product use case, and in this use case you have some point where the customer needs to make a payment, and you write the steps for the payment. and you decide that I will write the steps for swish payments because that's quite common in your scenario. And all of this is put into the order product use case. A few days later, you write the order service use case. At some point in the order service use case, you have the flow for payment, and you decide I will write the flow for swish payment. And suddenly you realize that I've already written this. So you go to the order product use case, you find the steps that are applicable for the pay, and instead of copy-pasting, you break that out into another use case called pay instead. And you include that use case in order product and in order service. So it's pretty much exactly the same thing as copy-pasting code. Instead of copy-pasting, oh no, I learned I should do a function, a method, or something like that instead. So you do that. And you do the exact same thing with the use case. And in this case, we also have different forms of making payments that probably have some steps in common that are encapsulated in the pay use case, but some steps that are special depending on how you want to pay. So this is the basic use case modeling. We kind of like avoid writing the same thing over and over again because it will be hard to read, hard to maintain. Instead, we do this small models. But the bulk of the work should then, of course, be writing the text for the use case themselves, the scenarios. Make sense? Yeah. There is another way to do this also called extends instead. I think that you should probably use include if you have the choice to do so. Extends is a little bit more complicated and a little bit more hard to kind of like use in an efficient way. It works kind of like in the opposite way. So at some point in order product, we decide that we will extend the steps using the pay use case. So it's a little bit the other way around, and it's not that clean. I call the function metaphor that we can use with the include use case. But it can be useful in some circumstances. So let me find the, here we are. So if the bulk of the work is about writing scenarios, we should learn a little bit about what scenarios are. So basically there are a step-by-step flow of events between an actor, that is a user of the system often. A user role can be customer, administrator, student, whatnot. And you write these step-by-step instructions with an actor goal focus in an essential terse style with the system as a black box. So you understood everything there? No. So first thing, actor goal focus. So the essence of a use case is that the actor should have a goal fulfilled, something that actually makes the user happy, or maybe the user's boss happy. If we look at the use case we had here, order product. Well, that's probably something the user actually wants to do. I would like to order a product. When it's ordered, and I'm happy about it. Something that makes our business go around, maybe. The same thing for order service, right? Goal level, user goal level use case. Here, the pay use case, on the other hand, it's kind of like at a lower level. End users will not be happy if they just do pay, right? Our customers would rather not do pay, probably. But as a business, we like pay. And we have kind of like this second level of use cases that's more a product of our use case modeling than a user goal. We have often use cases like this. For example, log in use case or authenticate use case. No one gets happy by doing that. You cannot tell your boss, I've logged in 15 times today. It will not make the boss happy. But rather focus on these use cases that actually provide some value to the actor or to the business. That's the starting point. And then you may end up with lower level use cases as a byproduct of modeling. So that was actor goal focus. Yes, essential style means that we should not specify the user interface. So we should try to not exactly say how things are presented to the user or how the user interacts with these items. Why do you think we want to do that?
Generate more use cases.
Could generate more use cases. Could you at least generate longer use cases? If we are supposed to kind of like write in detail everything that's seen on the screen and how it's presented, it can be quite complicated to do so. That is one thing. Other.
It's harder to keep a positive flow of events in the scenario if you have a lot of use cases.
Yeah. Scenarios tend to be quite complicated as they are, and adding a lot of user interface stuff will make them more complicated. The view might change. That's from the chat. That's a big thing. So if we specify in the requirements how everything should look, we don't, or at least risk locking down our system from a usability perspective, and we might miss on the opportunity to make things better in the project as we go along. So if we decide that, well, this should be presented in a table, and it turns out that it really sucks to have this presented in a table, then it can be really hard to change it because it's specified in the requirement, and the requirement is under contract, so we cannot change it. So we risk delivering something that we know is bad, but we cannot do really anything about it. So if we have the opportunity to not specify, we are open. We can decide at the point where we have the best information available. And we can change also more easily. And we don't have to rewrite the use case if we change. That's a good thing. And user interfaces are particularly prone to change. You always want to change the color or the layout or stuff like that. So it's quite good to try to write the requirements as user interface free as possible. So basically try to avoid words like table, clicks, menu, stuff like that. Try to keep it more neutral and focus on what is presented, what is the interaction that can be done. We will look at an example later. Terse style basically means use simple words. Don't write long, complicated words for the sake of writing long, complicated words. Often not a problem with engineers, because engineers don't like to write stuff to start with. So keep it short, keep it simple, avoid extra words. Not more complicated than that. So the system as a black box. What do you think that could be?
The boundary for the use cases?
Not really. Not really. Exactly. So we kind of like just view the system as a black box. We put something in it, something happens, we don't care, something comes out. We are interested in what we put in it and what comes out, not how it works on the inside. And that this is pretty much the same as the essential style, but the essential style focus on the user interface. The black box thinking focuses more about the technology inside this black box. So if we can avoid specifying these choices in the requirements, we are again open to use the best way of implementation possible when we know more. So instead of writing the order is saved in a database, in the MySQL server database, we can just simply say that the order is saved. We don't know how it will be saved. Maybe we will save it in a cloud service instead, because that was way better, way cheaper, way faster, way more secure. We don't need to care about running a database server suddenly. Or maybe we can save in text files, something simple. Maybe we can do something else. We are open to all these choices, and we don't need to lock down these choices in the requirements if we don't need to. So pushing decisions further along is often a good thing. If we don't need to decide it now, we probably should not decide it now. It's better to decide later when we have more information. So look at the system as a black box. For the scenario, we often have a pre and post conditions, especially for the main scenario, something that must be true before this use case can be initiated. Often you need to be logged in, authenticated as a certain type of user. Can be a good precondition. Post conditions are stuff that will be true when the main scenario of the use case has been successfully fulfilled. In our case, well, the order has been saved, for example. The order fulfillment process has been initiated. More or less the last step of the main scenario. So then comes the main scenario. That is the happy day scenario. The user makes all the right choices. The system behaves perfectly. Everyone is happy. Of course, this is not always true. Users can maybe make different choices at different points. The system is maybe not perfect. It can come into some error situations or tricky situations that need further input from the user. So we write these as extensions to this main scenario. So we kind of like, in this step, this can happen, but I don't want to clutter up the main use case, so I put this in a scenario a little bit further down instead. And these extensions have trigger conditions that says that, well, the user made this choice instead. This type of error occurred. I think one very important headline for use cases is the open issues. Because when you write a use case, when you meet with the user and you together develop a use case, you sit down and write down the flow of events, you are bound to miss out some details. And when you later come to implementation, you will probably not know how this will work or what is actually meant by this. And then you can use these open issues as a starting point to get more information. Because making assumptions, for example, regarding functionality or quality is not a good thing. You will assume something, someone else will assume something else, and the customer will assume something completely different. So one word for you might not mean very much, but for someone else it will have a big impact on the project. Let's take a look at this resource you have here. It's from a book called Applying UML and Patterns, and you will use it in 1DV607 to the autumn. And fortunately, the author has provided the chapter about use cases in this book for free, so you can take a look at this chapter. And it's very good, especially since it contains a quite detailed example of a use case. And here we have a lot of information that you can take a look at. We have the precondition here, for example, success guarantee or post condition. You have a scenario that's quite big. You have these extensions that can, stuff that can happen, quite a few of them. So take a look at this example, and here we have the open issues. Take a look at this example. I really hope that your use cases will not at all be this complex, but at least you can get a feel for what a use case actually is, and write one yourself. He discusses also a little bit about these levels of use cases, primary actors, how to write scenarios, and guidelines for writing scenarios within this example. So I think this is also interesting. Use cases are written and wrong, and that's often the case with requirements, that you write them down, you have a starting point, but you should also realize that they will need change, and they will need to be updated as we realize more about the actual system. So a little bit of a simpler example for is this order product use case. So I've not put in any pre or post conditions here, but rather focus on the scenario writing. So we start with the main scenario, and you always start the main scenario with a trigger point. And for me, the trigger is that the customer wants to order a product. During implementation, this will need to be translated into something that the system can recognize. Probably maybe that the user has come to our web page, he has clicked on a link or made a selection in the menu, for example. But since we're using this in an essential style, we simply put down that the user has indicated that he wants to do something, not how he has done this indication. Maybe he has done a, "Hey Google, I would like to order a product," or some voice activated interface instead. Then we describe how the system should respond. In our case, we would like to show the popular products. Since this is the Happy Day scenario also, the customer selects one of these popular products, of course. And the system responds by presenting detailed information about the product. And since this is the Happy Day scenario, the customer, of course, would like to order this product. So he confirms the order and proceeds to pay. And here we include the pay use case. When that use case has been successfully completed, the system confirms that the ordered product has been paid and that the order processing is initiated. Looking a little bit at on this text, you can see that it's not really describing the user interface. We can imagine that popular product is shown in many different ways. Could be a table, could be images, could be anything really. But the system should at least be able to show them in some way. We have not described how the user selects a product, but rather that a product can be selected, and so on and so forth. We have not stated how the order processing is initiated, but that it is initiated. So black box. And I have at least tried to not add any extra words. I actually deleted the customer, the system, the customer, the system from this text because just adding the, it's better English, but it's really not needed. Some extensions. Naturally, maybe the customer would like to order additional items. So in step number 5, instead of confirming the order, the first extension in step number 5 is that the customer wants to order additional items. And then we can describe what the system should do, and maybe even we should just go to main scenario step 2 and show the popular products again. So you can weave these together, the scenarios, also by using statements to go to another scenario, or repeat the scenario steps until someone is satisfied, or something like that. Something realistically that could realistically happen is that the payment was not successful in some way. So in step number 6, we can encounter maybe an error, or that well, the customer did not have the funds available. You can probably make this more fine-grained also as you go along. And if the customer does not have the funds available, maybe we should offer credit if it's a good customer that has many paid orders before. So we can imagine writing more detailed and better scenarios here as we go along. So basically, you write the main scenario, everything works out, everyone is happy, and then you add the extensions. And a guideline is to add extensions for if the user can do a different choice of some sort, then you add that extension on a user line in the scenario. So in my case, I opted to say that in step 5, the user can select to do something else. If it's more of an error situation that the system kind of like detects or generates, the guideline is to use the system steps for that. So for number 6 there, we had the payment was not successful, and it's more of a error situation than a user choice. So I put that in step number 6. But you can check out the Larman resource. He has a lot of extensions, and you can put little stars to cover all the steps, for example, and stuff like that. And if I have another selection in 5, for example, then I put down 5.2. What choice did the user make? And then I can write an extension scenario for that. So, open issues. Can you see any open issues in this scenario? If you were to implement this or got this, well, here you go, this is your task for today. You should implement the main scenario. We expect it to be working in 2 hours. What would your first question be? Yeah, it's missing a little bit of context, and you don't really know. We don't have the preconditions, so maybe you can like, oh, is the customer registered already? Stuff like that. But something a little bit more concrete. What would your questions be if you kind of like had a system that was going? We're going to add kind of like this order product. We have a product database and stuff like that up and running already. Yeah, when doing implementation, we kind of like need to make a lot of decisions. So we need to decide on how do we want to show this. So we need to make a decision that can be something that we make either on the fly. You make the decision, I put this in a table, I show images. And then we wait for user feedback and we improve as we go along. So that's definitely something to ask about. Do we have any standards for usability? Do we have other pages that we should kind of like, should it look similar to this other user interface stuff that we already have? Definitely. I would probably ask, how do we know that a product is popular? This seems to be something that is could be quite complicated. Should we go kind of like on what's most viewed, what's most sold? Should it be something more advanced than that? Maybe if the customer is logged in, we could use some history of browsing for the customer. and show products related to that. So that would be something that I would probably react upon, because I would not I know how to kind of like show stuff on a screen, and yeah, we can tweak the user interface as we go along. If you don't like it, we can change it. But knowing if a product is popular or not is something that I would not immediately kind of like have a feeling for how I would do. So that would be something that I would either allocate a lot of hours for in my estimation, or need to ask someone about. Customer selection, well, that depends a lot on how we decide to use this user interface. I can kind of like see a few choices, but the user clicks the product if it's a web system that we are developing. Should not be that hard. Detailed information about the product. That's also something I think that should be an open issue. What is this? And especially if it contains maybe more than we think. So thinking about detailed information, I kind of like think of, well, it has a name, it has a description maybe, it has a part number maybe could be important in some systems. But there might be images, many images. There can be other forms of media also, movies. It could be user ratings. Could be all sort of stuff that we have kind of like put into this word detailed information. So that is also something I think should warrant further investigation, because it can mean so many different things for different stakeholders. So as a developer, I kind of like immediately think about, well, in the database we have a product table and it has these columns, and that's what I'm supposed to present. But an end user might want to see the reviews for this product instead, or the YouTube movie or whatnot. Maybe we have a lot of stuff like that. That's actually the detailed information. So again, don't assume. You need to be a little bit careful about these words, because they have a tendency to mean different things to different people. Yeah, and of course we need to know more about how order processing works to be able to implement this, but it's not maybe really part of the requirement as it is. So those are maybe the most two pressing open issues I would at least have with this requirement. I don't know how to determine a popular product, and I would like to have a better specification of the detailed information and how it's supposed to be shown, and possibly maybe some user interface guidelines also, if I'm supposed to implement that usability stuff. So I think open issues headline is very important, because it will give you a list of items that you need to take to the end user, take to the customer of your system, and ask them about. The rest of the steps are quite clear often in use cases, because you have developed them together with the user and the customer, so they should be quite clear. But any open issues are still stuff that's uncertain, and you want to get rid of uncertainty as soon as possible. Questions? Does it seem hard? It's not too hard, actually. I think if you follow these kind of like simple guidelines, try to keep the user interface out of it. One-step user, one-step system, input, output. Try to be a little bit specific. Try to treat the system as a black box. Don't describe how things work inside, but rather what the user sees or gets. Write simple steps and start with a nice main scenario, and add the points of selection or error points afterwards. You will be fine. Start with a trigger. Many people forget that. The first step in the main scenario should be a trigger, something that the user wants. Right? No questions? You have requirements probably in your vision, like these high-level features. So I guess a requirement would be that, well, you should be able to play the game. It's a fairly high-level requirement. Yeah, in scope, you have a lot of scoping information because this is a course in the university, and you have these weeks, and you have a finite amount of resources, and you have deadlines and stuff like that. And you can also think about scope like, well, the first step is to get kind of like the passing grade for everything. If time permits, I will add extra features to possibly have a higher grade. So that is something to think about when thinking about the scope. We could probably invent a lot of interesting requirements for this little project, but since you are limited in time and resources, the scope needs to be kind of like semi-realistic, or at least in some way prioritized. And that's a big thing actually among with the requirements, that as a project goes along, you will always face the question of what is the most important thing we can change right now. So maybe if we work in iterations, we have a delivery every 4 weeks or something like that. And we need to kind of like at the start of the iteration decide on what we're supposed to work on. And that's not an easy thing to do often, because you have maybe a lot of bugs that you need to prioritize, you have new features that you want, you have competition that has added new stuff that you would like to keep up with. So it's always a game of finding the right things to change in your system versus bugs versus new features that you actually can manage during the iteration. So prioritizing is key. And in this course, go for the passing grade first, and then possibly add extra stuffs towards the end, so that you can get a higher grade, if time permits. And time flies. Other questions?
If we were to add extra features, would we have to edit our vision later on?
I think you should, the vision you can regard as a vision. It's not a contract. So you can write the vision as something, this is what I would like the product to actually be. This is the shit at the end. But as scope and resources are limited, this was what it became. If time permits, depending on skill and effort, other courses, life in general, we can have a kind of like a sliding scale there. So don't see the vision as a contract between you and the kind of like the course. Regard it as a vision. Given a lot of resources, a lot of time, everything works out as planned, then we can fulfill the vision. But we will end up probably in some place between bare minimum and total success. And I think vision is vision. So it should be something to strive for always, something that you may not even ever get to. The best hangman project ever. Because also when doing this is actually something that maybe if you have your own projects, you will sometimes kind of like spend so much time on one little detail, hours and hours on some really unimportant detail that kind of like, oh, I just would like this to be 1 pixel to the right if it's a user interface thingy, or I want this code to look a little bit neater or be divided in some other way that could possibly make it better. And it's really, really easy to lose perspective. So it's really easy to just dig into that little detail and not care about that 95% of the system is crap. But this little thingamajig that I'm working on, it's super duper and it's gold plated and platinum and everything. But the rest is just nothing. So kind of like being able to lift the view from time to time is a good thing. And you will probably get into a situation where you kind of like spend a lot of time on something and it's a dead end. You need to kind of like back out and abandon it, do something else, take another route. Well, I cannot really figure out how to do this functionality, but maybe we can do something similar if we do it like this instead. So situations like that are really, really hard to recognize, because often as engineers we are quite proud and we would like to really understand stuff from a detailed point of view and really dig into something, and we may lose perspective. So should the vision be abstract or descriptive? Like it should be colorful with, it will be a green-red application, dummy example. I think you should have a good balance there. I think it's good if the vision, at least in real projects, can inspire. Should be something that you can feel that, like, yes, this will kick ass. This would be a really good thing. So it's good if the vision can inspire. At the same time, it should not be totally unrealistic, and it should have some grounding in reality also. For example, well, I have 2 months. I will construct a social media site that will beat Facebook in number of users. Well, it would be really awesome, but probably not that realistic. So try to find a balance between visionary, inspiring goals and reality. And for this course, I would probably gear a little bit more towards the reality way. So maybe not add real-time OpenGL support for graphics, but maybe add high score as something, a good feature to have in your application, if time permits. All right, anything else? Not? I think it's time for lunch, so let's finish.